Let's continue our counting journey. So right now we're going to take a look at cases. And before we get started into cases, cases are a really simple way of breaking a more complex math problem into simpler ones. And you may not be able to solve the complex problem, but you're able to solve the simpler sub-questions in a pretty straightforward manner. So look for the large question and look for if you can spot out the simpler questions within the larger question. If a counting problem has one or more conditions that must be met, consider each case that each condition creates first and add the number of ways each case can occur to determine the total number of outcomes. I'm just going to maybe put the word or here. Now, generally speaking, more often than not, if we say the word or, it implies an addition will occur. If we use the word and, we just have to use the correct one, it will imply multiplication. So let's get started. For example 4, consider the letters in the word math. There we are. I spelled them backwards just to get rid of the context of the letters. How many total words are possible using any number of letters without repetition? So really, we're going to create different words using the 4 letters of math. We can use any number of letters. Well, you got me, any number of letters. So this is where case starts. So really, you could say this is really, really complex because I could use one letter. Or, now there's that or I could use 2 letters. Or I could use 3 letters. Or I could use all 4 letters. Now, this is a permutation because order will matter. The order of the letters really do matter. So I am just going to ask myself easier questions now. How many different words can I create using only one letter with 4 elements? Well, I have one decision to make, and that is 4. I could make 4 different letters. 4 different words. Now here, how many different words can I create using 2 letters? Well, if you want, I could write the word math out again. And I'm going to use the fundamental counting principle here. This would be 4 times 3. And if you're using P notation, it'd be 4P2. That is, out of 4 elements, you're picking 2. Now, 3 letters, so I'm just going to say 1, 2, 3, using the letters in math. I will have 4 choices for that first letter. For that second letter, I'll have 3 choices. And for the third letter, I'll have 2 choices. Or if you want, you can say, well, it's 4P3. So from 4 elements, I'm going to pick the order of 3 of them. Now, the case of 4 letters, well, I'm just going to put those. So I have 4 choices for my first letter. 3 letters for my second letter. 2 choices for my third letter and 1 for the last. So in each of these cases, we'll get a numeric value. So there is 4 possible ways that I can make one word letter out of HTAM. Now in case 2, this can happen in 12 different ways. It's 3. 4 times 3 is 12 times 2 is 24. Last but not least, 4 times 3 times 2 times 1 is 24. So quickly adding these up. Now, do you see the word or? Pardon me, that was the wrong tool. Do you see the word or? or. This implies addition. So what we're going to do is we are just going to add each one of the number of outcomes in each case. And I believe that is 64 possible ways that we can do that. Now, I'm just going to maybe quickly do that. I apologize. Now, Brooke. Brooke needs to create a password for a social networking website she is registered with. The password can use any digits from 0 to 9 and any letters of the alphabet. The password is also case sensitive, so she can use both lower and uppercase letters. Well, let's talk about the number of elements that we're talking about. I guess we have digits, and then we have uppercase, and then we have lowercase. Well, digits, there's from 0 to 9, there are 10 of them. Uppercase, there's 26. And lowercase, there's another 26. Maybe no special characters. So what I get is there are 62 possible different characters that I could use. So if I must create a password that is at least 5 characters to a maximum of 7, and each character can be only used once in the password, how many different passwords are there? Do you see the smaller questions within the larger question? There's different scenarios. And you may say to yourself, well, I could have a 5-word password or 5-character password. I could have a 6-character password, or if I could have a 7-character password. And I would say, yeah, you could have that. And this is probably really represented really well by cases. So case 1, I'm going to have 5-letter password. So case 1, I am just going to have 5 letters, and I have, that was 62. Out of 62 characters, I am going to choose the order or pick the order of 5. And if I want, I'm just taking out my fancy calculator. Maybe you want to calculate with me. If I choose 5, that is a lot. Wow, that is a lot. So I believe it's 776,520,400 or 240. Now this next one, case 2, with 6 letters. So out of 62 characters, I'm going to pick the order of 6 of them. And this gets really large. And if I pick 7, it is really, really large. So these numbers, I'm just going to write it maybe in P notation. So out of 62 characters, I'm going to pick the order of 7. So really, how many? Well, it's really staggeringly large, so large that my calculator sort of gave up on me. But it would just be 62 P5 plus 62 P6 plus 62 P7. And this is well into the billions, if not hundreds of millions, perhaps trillions. I don't know. This is a lot of different passwords. Maybe this answers the question, why are there all these conditions on passwords that you must choose a capital letter, a lowercase letter, a special character? It's because it creates so many different passwords that they're hard to guess for possible hackers.